Recording. Good morning. I'm Steve Gordon. I'm the current chair of the SIG HPC Education Chapter, and I'd like to welcome you to our webinar today, brought to you from Morgan State University. So I will turn it over now to our speaker, Dr. McCarthy. Could you introduce yourselves, and then you can begin your presentation.
Sure, thank you. My name is Pumtit McCarthy. I'm an assistant professor at Morgan State University.
Hello, we can start the presentation, and I think that we have the introductions also, short bio, right?
Sure, so I'll share my screen now.
Okay, then start that. Good morning, everyone. I hope you have a beautiful morning. Over here in Baltimore, it's raining, but it's still a beautiful morning. It's not the white stuff, so we are happy about that. I am Jigish Zaveri, Professor of Information Science and Systems at the Earl Graves School of Business and Management. And this is my colleague.
I am Pumtit McCarthy, Assistant Professor at Morgan State University. And would you like to talk more about your?
These are our short bios. I'm a professor in information science and systems. Like I said before, I have a varied background. My PhD is in MIS, and my master's and bachelor's degrees are in chemical engineering. I have numerous publications, and I do active research, and it was fun to, and it was very good to work on this project, and we'll talk more about it.
Hello, I'm Pumtit McCarthy. I'm an assistant professor of chemistry here at Morgan State University. I received my bachelor's as well as my doctoral degrees in biochemistry. Before I joined Morgan in 2013, I completed a postdoctoral fellowship at the Food and Drug Administration.
Now, a little bit about the webinar outline. Like we said, we'll go through the introduction about us and then about the subject matter, and we'll talk about the goals of the program and other things. And this is the webinar outline. Let's go to the next transparency. Can you see the screens?
Sure.
No problem. Keep going.
Okay. Again, here's a webinar abstract, and as we can read, as part of an AACU funded teaching initiative, and that stands for American Association of Colleges and Universities, Morgan State was one of the 20 universities that were selected for this program. And Morgan State University, we had an interdisciplinary team of administrators and faculty members from several schools and colleges. And I think the next transparency would give you the list of schools and colleges. As you can see, my colleague is from the chemistry department. I'm from information science and systems, so we are from different departments. And the interdisciplinary team consisted of faculty members and administrators from the School of Computer, Mathematical and Natural Sciences, School of Education and Urban Studies, School of Business and Management, School of Engineering, and College of Liberal Arts. So basically all the major schools and departments are at the university. Let me give you a little bit about Morgan State University. Morgan State University is a preeminent public urban research university, and it enrolls a diverse undergraduate student population. Morgan State University was established in 1867 to train young black men for the ministry, and is evolved into a public coeducational, comprehensive Carnegie classified doctoral research university. It has been named a national treasure by the National Trust for historic preservation. In the state of Maryland, MSU is the largest HBCU and has been designated as Maryland's preeminent public urban research university in 2017 by the state's legislature. MSU has the responsibility of addressing the needs of the urban populations of the city of Baltimore and the state of Maryland. It has an ethnically and culturally diverse student body and offers a range of programs leading to degrees from the baccalaureate to the doctorate, as well as offering programs in research and public services. As I said earlier, MSU enrolls a diverse undergraduate population with over 60% supported by Pell Grants and a large percentage of first-generation college students. With this population of students, there are several challenges to degree completion, such as more than 65% of first-time freshmen test into developmental courses and have some kind of financial as well as other situations. In 2015, MSU, under the leadership of Dr. David Wilson, launched a very elaborate program, the 50 by 25 campaign, which focuses on increasing MSU graduation rates to at least 50% by 2025. Now, with respect to this, we have designed this program, and I would like to talk more about the goals of the program. The Morgan MTIDES program, or in short, it was teaching to increase diversity and equity. And as we can see, Morgan has a very, very diverse population. And we have one of the major goals of this program was to graduate a workforce skilled in data science. With respect to that, we wanted to introduce or infuse, and we have succeeded, and we are currently also in the process of implementing it in a lot of our courses, the CDS, Computer and Information Science tools, into basic science courses like chemistry, biology, physics, math, and computer science. In today's program, my colleague, Dr. McCarthy, would be talking about a course that she has implemented in the chemistry department. Another goal for the program was to empower the Morgan faculty to effectively integrate these tools and implement culturally sensitive pedagogy into their practice. To this extent, we designed several, before we attempted to make changes in our classroom pedagogies, we tried to change our attitudes, our behaviors, and our expectations, and we were increasingly mindfulness about the need for attention to the diversity of the students. Goal 3 of the program was to develop a certificate program in computational data science that targets both not only STEM students, but also non-STEM students at Morgan State University. And another goal of the program, we have 4 goals, was to foster this sustainable institutional change at Morgan State University. That is, continue implementing these ideas, these programs through a systematic implementation of CDS strategies and instructional strategies. Let me give you a brief background about what is cultural responsiveness, because sometimes a lot of questions are raised, and the way we look at it, cultural responsiveness is the ability to understand, communicate, appreciate, respect, and interact effectively with persons of various cultures. Especially at Morgan, we have a very diverse, underrepresented student body, and this really fits into not only the student population, but also the faculty population is quite diverse also. The CRTP principles that we wanted to basically incorporate were things like having physical hands-on activities in classrooms, in courses in biology, chemistry, information science and systems, computer science. A lot of these activities were designed. The results were shared among the faculty. The focus was also on students, which means we wanted to incorporate more student-led discussions and teaching opportunities in the classroom. And Dr. McCarthy will be talking more about that in her personal experience. Finally, we want to involve students, basically have student apprenticeships and have students discuss these things in their classroom, in their educational experiences. When I come back to goal 2, I wanted to talk about some of the workshops that were developed to have this idea spread, to get faculty also competent in these techniques and technologies. There were several workshops held: cultural competency, computational and data science workshops. There were workshops that were held, whole day workshops on, for example, uses of big data, R, parallel R. And of course, we used the XSEDE environment, and XSEDE has had several workshops on the campus where we discussed, where faculty from different departments discussed their activities that they would implement in their courses that would include computational data sciences and cultural competencies. Faculty attended TIDES institutes. Like I said, the focus was on culturally responsive teaching, CRT. And one of the major, I think, advantages of such workshops were we were able to brainstorm. Faculty was able to brainstorm about different ideas, and we were able to discuss thoughts without any limitation. And it was a safe and encouraging environment. We were introduced to a lot of pedagogical concepts, and XSEDE had helped us to implement a lot of these things. Now, the faculty activities on campus involved all of the courses. For example, we had several project meetings where we would discuss the different courses, what faculty were doing in their courses, course redesign meetings, assessment activities were performed, individual interviews with not only faculty, but also students and focus groups, and several classroom visits and observations. But here's an example of one of the XSEDE workshops where we learned about CDS integration techniques, and here's a snapshot. It was a wonderful atmosphere, environment. A lot of tools were introduced and covering a whole bunch of different disciplines, from information science, mathematics, chemistry, physics, biology, and so on. Now, I would like to give you a personal experience about this with respect to one of our courses, and Dr. McCarthy is here. She's from the chemistry department, and I will turn the presentation to her. Thank you.
Thank you, Dr. Savari. Good morning once again. I'm Pumpkin McCarthy. As mentioned earlier, I'm an assistant professor of biochemistry in the chemistry department. And for my course, the 2 biochemistry courses that I teach, I infused computational data science within them. So I'll be presenting today about how I use molecular visualization as a tool for culturally sensitive teaching in biochemistry. So 2 biochemistry courses were where we had this implementation of the computation modules. Chem 304 is a required course for junior and senior chemistry and biology majors. The typical enrollment is around 18 to 24 students. Occasionally I have majors such as engineering, math, and physics. Chem 202 is a required course for sophomore medical technology majors, as well as senior nutritional science majors. And typical enrollment is roughly the same, about 16 to 20 students. And I've had a high of 24 as well. So Chem 304 is usually offered in the fall semester, whereas Chem 202 is offered in the spring. So the basis of my module was basically trying to get students to understand the different levels of protein structure, which I have schematically here. So when we think about proteins, we can think about the particular primary structure, which we refer to as the amino acid sequence. And then the next level would be the secondary structure of proteins. And so finally we get tertiary structure, which is the final folded form of a protein. And some proteins actually have what we call quaternary structure. So this module is based on trying to get students to understand how changes on the amino acid level lead to changes in the final folded form of the protein. And the test case that I used for my module encompasses cultural competency and relevance, and this is sickle cell anemia. Sickle cell anemia is caused by a change in the protein hemoglobin. Hemoglobin, just to familiarize everyone, is a protein that's found in red blood cells, and it's involved in oxygen transport in the blood. And essentially, sickle cell anemia is caused by a 1 amino acid change in the protein. It's an inherited disease that's caused by mutation in the gene that codes for the protein hemoglobin. So this 1 amino acid change is really a change initially at the DNA level, which leads to a change of the amino acid, which leads to a change in the protein. So hemoglobin molecules that have this change are not able to carry oxygen efficiently, which leads to anemia. And this disease causes sickling of the red blood cells, which I've tried to point to in the picture on the left. So that's why sickle cell anemia is referred to as that, because of the sickling of the red blood cells. So for my module implementation, I had students really working on the central dogma. And the central dogma tells us that DNA is transcribed into messenger RNA, which is then translated into protein. So using sickle cell anemia as a basis, the students were able to look at DNA changes and how those changes reflected on the protein level. So students, in this module, students visualize the protein structure of normal hemoglobin and sickle cell hemoglobin using open source protein visualization software. Students also manipulated and labeled structures and answered targeted questions related to that. So some of the open source protein visualization software we used is from an XSEDE tool, the bioinformatics software database XSEDE. We used Swiss PDB viewer. Also, students were able to download the amino acid sequence of the protein from the protein data bank. The students using this module manipulated and labeled structures and answered targeted questions. Students used online bioinformatics software to translate the messenger RNA sequence to protein and align the sequences to determine the sites of mutation. So this was also done using some XSEDE free open source software. Students answered targeted questions and performed manual translation of the sequence. When I say translation, basically looking at the DNA message, looking at what the RNA would be from that and what the amino acids would be from that. So bringing it back to how this module fits into our goal of infusing computational data science as well as cultural relevance, I want to say that as part of our MTIDES meetings and workshops, we basically met and came up with some basic protocols or tenets that we wanted to assess infusion of computational data science, as well as cultural competence and responsiveness. So first, the 18 tenets that were used to assess integration of computational data science are the following. And these were derived from the core basic simulation and modeling competencies that were provided by XSEDE. So we wanted students to be knowledgeable of the computational tools that they were using. We also wanted them to be engaged in the course content and activities. We wanted to make sure that the computational tools were being used correctly by the students, as well as we wanted the students to have a good enough understanding so that they'd be able to recognize any errors given by the computational tools. We also wanted the instructors, so once again, these infusions were done across many courses, but we wanted the instructors to incorporate the use of data, as well as for having the students understand the data and data sets that were being used. We wanted students to be able to have productive conversation with other students regarding the tools, and also to be able to use the knowledge gained to quickly resolve problems related to the computational tool. In addition, we wanted students to complete this assignment, which involves computation in a timely fashion. And also, we wanted to set these modules up in a way so that students needed minimal help from the instructor to complete the project. And also, just to have an equitable environment, learning environment, we needed to have all students to have access to the necessary computational tools. And the final tenets related to computational data science, we assessed whether students were going to be interested in the class, whether students utilize their peers for help with problems, whether students use more than one computational tool in the course, and whether students had an understanding of why they were using this tool. Also, instructors needed to use computational science tools for modeling and simulation, as well as instruction that had incorporation of computational programming or use higher level language or modeling tools. As well as we wanted the instructors to have incorporate engaging team-based real-world projects. So all of the 18 tenets that I've outlined, once again, as we met as a team, we used these basic computational data science protocols in our courses, and then our evaluation team, when they came to observe our classes, basically used these protocols to see if we're, how much we're following everything. So for my course, and this observation was based on a Likert scale, where 1 is the lowest and 7 is the highest. In my module, all 18 were observed, and then I've highlighted in red the ones in which a score of 7 was received by the evaluation team. So students were interested in the class, students understood why they were using the tool, they were using modeling and simulations in the work, and then it was also engaging in team-based real-world projects. So that is a description basically of the module in terms of the computational data science. Next, I want to talk about the culturally sensitive teaching components of my module. So as my colleague Dr. Zveri mentioned, we met as a team as well and came up with 5 culturally sensitive teaching protocols that we agreed as the MTIDES team were important for our courses to all have, to really say that we're incorporating culturally sensitive teaching. So once again, protocol 1, we want to incorporate physical and hands-on activities in instructional practice, incorporate more student-led discussions and teaching opportunities in the class. We want faculty to become conscious of biased judgments about the students based on limited perceptions of them and be willing to change these perceptions. Protocol 4, we wanted students to have student apprenticeships that foster empowered learning communities. And protocol 5, we wanted students to use their lived experiences as content for the activities in the course. So once again, I just want to bring up sickle cell anemia in terms of the cultural relevance of the disease. So sickle cell anemia is a disease that affects millions of people worldwide, and it's particularly common among those whose ancestors come from sub-Saharan Africa and Spanish-speaking regions in the Western Hemisphere, including South America, the Caribbean, and Central America. We also see sickle cell anemia in Saudi Arabia, India, and Mediterranean countries such as Turkey, Greece, and Italy. In America, it's estimated that sickle cell disease affects approximately 100,000 Americans. And it occurs in 1 out of every 365 Black or African American births, as well as 1 out of every 16,300 Hispanic American births, according to the most recent data from the CDC. So once again, in terms of my module, thinking about it now in terms of cultural sensitivity, the module hit, or Protocol 1 was present in terms of, this was a student-led protein visualization project. I really only early on gave a brief introduction about what they would be doing, but the module was really a step-by-step sort of thing where that they can follow the steps outlined in the module to complete the project. Also, this relates to Protocol 2 in a way, in that students were able to learn from one another about how to complete the protocol. Of course, if they had some simple questions, I would answer them, but they really worked in groups in terms of completing this project, and they worked within their group as well as across groups on how to complete the assignment. Protocol 3, all students were treated in an equitable fashion, and all the resources were made available to the students so that they can complete the project. For Protocol 4, it all sort of relates to things I've already said, but basically students were able to work collaboratively with groups and across groups so that they were really learning from each other the best way to complete the module. And then Protocol 5, as I said, this module is based on sickle cell anemia, and this is a molecular-based disease, and I sort of outlined the disease incidence in terms of the African American community, and some of the students, while discussing or performing the module, actually sort of said, you know, I have a family, or I know someone who's been affected by sickle cell disease. So this, I think, is really one example of how students' lived experience is being used as course content. And then I just wanted to highlight one explicit learning goal in terms of the cultural competence and sensitivity aspects of this module. So one of the explicit learning goals was that students will understand the cultural relevance of sickle cell anemia, and they should be able to report the global incidence of the disease. And this was assessed through a problem in the assignment, through summative assessment. So I mean, in terms of the biochemistry, they are using protein visualization to see what effect this one amino acid change has on the protein and how it relates to hemoglobin and sickle cell hemoglobin. But I also wanted them to relate that back to the cultural relevance in terms of understanding the rate of occurrence of sickle cell anemia, what racial populations are affected most by the disease, as well as what are some symptoms and what types of cures exist for the disease. So since implementation of this module, which I implemented initially in my Chem 202 course and have been doing in Chem 202 and Chem 304 since then, a diverse group of 74 undergraduates from many cultural backgrounds learned about sickle cell anemia as well as the disease incidence. And then this past spring, I implemented this module in a graduate biochemistry course as well. And then thinking about some of the demographic data of our students, in the 2016-2017 cohort, 22 participants identified themselves as African American, which is 64%. 6% students were Caucasian, which is 18%. 5 were international, which is 15%, and 1 was multiracial. So I included this just to show that yes, Morgan State University is a historically Black college and university, but we're also becoming more diverse in terms of the students that are here. We have an increasing amount of international students. So I feel that this MTIDES project relating to infusing computation as well as cultural sensitive teaching protocols will be reaching a larger number of more diverse students. And I will end by saying that the module was successfully introduced to students to have them understand protein visualization and also reinforce their knowledge of the central dogma, which they had learned about in the course as well. For future work, I'd like to design new biochemistry modules to incorporate culturally sensitive teaching and computational data analysis. I'd like to expand the module or whatever new module I design to incorporate XSEDE tools, such as I know XSEDE has Rosetta, so that'd be interesting in terms of students to actually think about designing protein structures. Also, I'd like to perform appropriate pre- and post-assessment of this module to determine learning gains from this. So now I'll turn it back over to my colleague, Dr. Zaveri.
So, thank you, Dr. McCarthy, and that was just one of the courses that that was designed at Morgan and that was developed by the Morgan State faculty members. As you can see from this list, the workshops, the XSEDE workshops were focused on active learning, student-centered pedagogical approaches, and assessment. The trained faculty members from all across campus, as I mentioned, from across different schools, began implementing these active learning modules within their courses, which impacted their courses, and using the CRT principles, the principles that Dr. McCarthy highlighted, we were able to measure some assessment or measure the outcomes of these programs. One of the key things was faculty showed an increased willingness to integrate more computational data tools and techniques into their courses. Among some of the several tangible benefits, of course, the class performance improved across board, which means it will help us in retaining students, which help us reach our goal of 50 by 2025. However, there was one very tangible result of this program, and that was the development of a certificate program in computational data science. And this certificate program was designed by different departments of by the different departments from Morgan State University, all the way from biology to sociology, as you can see from that list. And I may have missed a couple of departments over there, but I hope I've covered all. The main highlight attraction of this program was, and I will go to the specifics, it's an upper division certificate program, and it is designed as a 15 credit hour certificate course, where the core is made up of 9 credit hours, where you would take courses that are required in computational data sciences, and then the students would have the option of choosing 3 more courses from an inventory of currently 6 courses. So that they can get certification in this program under different disciplines. All courses require computational analytical techniques that can be applied to data sets. Now, this program has been highly successful, and as we said, we have had several surveys conducted to assess the program, the success of this program. And here are some, although we have statistical data, here are some anecdotal data, that is some quotes. For example, one of our faculty members said that MTIDES project was responsible for promoting a broader computational thinking environment by expanding the number of courses being taught and faculty investing more time and effort into implementing computational data science into their courses, using software, using the tools that are provided by XSEDE. Another quote, with the right tools for analysis, big data is just data to answer questions, solve problems, make decisions, and plan strategies. Of course, from one of our business professors. The MTIDES program has facilitated the engagement of multidisciplinary work among faculty with very diverse, both academic and cultural backgrounds, and will definitely foster more research. As you can see, I am from the School of Business. Dr. McCarthy is from the School of Natural Sciences in the Department of Chemistry, and we had faculty from a lot of different disciplines across the campus that met at these workshops. They had good brainstorming sessions where we discussed different teaching techniques, different experiences that we had. And like some of them said, and this is one of our administrators, I'm impressed by the open-mindedness and commitment from the MTIDES team. The faculty and staff worked beyond expectations and supported the project without reservations. Better courses, these ideas were implemented in our lectures, and that got our students more engaged, especially when we did computer simulations with the data. Finally, TIDES was transformative by increasing faculty members' understanding of culturally responsive and, of course, student-centered teaching in STEM. And that's, thank you very much. I hope I haven't used too much of the time. We have some time for Q&A. Here are our participants. Again, I would thank Steve Gordon. And would you like to say something about this?
Yes, so we'd also like to thank Kelly Mack. The MTIDES program was supported by the Leona and Harry Helmsley Charitable Trust. So we thank them and AACNU and Kelly Mack for the funding. So we'll take any questions. Thank you.
Thank you very much for the presentation. This is clearly one of the most comprehensive efforts I've seen to integrate computational science into the curriculum. So we will take questions now. You can either unmute and ask them verbally, or you can post something in the group chat, and I'll pass that along to the presenters. So while we're waiting for others, I have a question now, or I'd like to urge you, in fact, it looks like you have some comprehensive data on the success of your program, and I hope that you're looking to try to publish this. And as the editor of the Journal of Computational Science Education, I would certainly welcome a submission or two. As I said, I think this is one of the most comprehensive things. One of the questions I have is a follow-on. Are you following students now as they graduate to see if this has an impact on things like people going to graduate school or employment or those kinds of things?
That's a great idea, yeah.
Yes, I think, yes, in fact, I would say that yes, we are following it, but not particularly specific to the MTIDES program. We have graduation data, we have data, we have alumni data about where our students are going, but I don't think we have aggregate data about the success of this program. But I don't think we have followed any specific students through the program and followed them as a case study. If that answers the question.
Yeah.
But we have seen a lot of success in, in Dr. McCarthy's class and other classes. We looked at the pass rates. We looked at the graduation rates or the passing rates, the grades that students receive. And in some of the courses, especially I know in one of the courses I taught in information science and systems, there was a marked improvement in student performance and engagement. And so these were measured for the individual classes as an aggregate, but we do not have specific student data.
Yeah, I would just encourage you to think about that, because I believe when students are engaged in this way and get a deeper understanding of the material, it may actually change their view of what careers they wanted to pursue, and it would be an interesting thing to sort of follow and ask the students that have graduated, you know, what impact the program has had on them. So I think that might be a neat follow-on, but if you get the resources.
Oh.
Yeah.
I think that's a great idea, yeah.
That's a great idea. I mean, and one thing I would say that in the short term, we can see the sparkle in the eyes, especially when you have some simulation done and you look at the amount of data that they have crunched to get the result. And that is quite impressive, that is engaging. So I think there is short-term benefits. Long-term, yes, we need to measure that, and that certainly would be a great project.
Yeah.
And I hope Dr. Quanta and everyone is listening to this.
Excellent. Are there other questions from the audience? I'll ask another one then. You mentioned XSEDE. For these protein simulations, were you actually using XSEDE resources or local computing resources?
I was not. So this was basically using online software,
Okay.
so open source from XSEDE tools.
Mm-hmm.
Yes, but so this is my sort of first iteration of the module. So now I'd like to extend that to now incorporate XSEDE tools.
Okay.
Mm-hmm.
Yeah, the online tools were, I assume, were easier to implement in the short run.
Yes, yes. So now that I think I've gotten that down, I think now I can branch off and start using some more computational tools that XSEDE offers.
Right.
In fact, I would like to say that last time I visited XSEDE, I mean, I think that you have spruced up the website, and there's a lot of help now available. I mean, it's got more user friendly.
Well, that's good to hear.
Yeah,
that's good to hear.
But for courses, it's always, we have software available for my courses also, and it's easier to use that software that is provided by commercial vendors.
Right.
But it would be great to use XSEDE tools as we go along and integrate them in our courses.
Are there other questions?
Okay.
Yeah, go ahead, Dr. McCarthy. Were you going to say
I was
something?
going to say one of my colleagues, who actually I think is online, Dr. James Rotera, uses XSEDE quite a bit in his research, and I could always get tips from him about how to incorporate that more in my classroom.
Yeah, I mean, I was just curious. It's not absolutely necessary. It depends on what your academic goals are, but I'm just curious.
Mm-hmm.
Are there other questions from the audience before we close for today? Do you have any here's a thing that got posted. Do you have any recommendations for other programs of hurdles that you overcame in this process? So if somebody else was to try to mimic what you did at Morgan State, what were some of the things that that you think made it successful that would be hints to other institutions?
I think one of the key things is the support from the administrators and the resources that are provided. And it was wonderful that we had organizations like XSEDE conduct workshops on campus that got faculty interested and become aware of these tools. And it's always a great idea that if we get funding, like I said, I think this is still a work in progress, I believe. And Dr. Quanta and all the people would agree with me that yes, we have achieved some, but there's long ways to go. And if we have the support, for example, you gave us a wonderful idea, that is, how do we measure the success of this program? Do we have some data that we can collect to support the success of the program? Yes. So one of the key things is funding and resources made available to the faculty. And of course, then the motivation comes.
And faculty buy-in as well.
Right, faculty buy-in. Especially when you have workshops that are well organized. And in this case, I believe, I think Morgan State University did a wonderful job with very limited funding. This program was there for 3 years, and it involved a lot of departments across campus. So I believe it's something that should be implemented and with more resources.
Okay.
You would like to say something?
No, I think you said it all.
All right. Any other final questions then? Well, if not, I would like to thank you again for your excellent presentation. And for those that are listening, this will be, recording will be posted on the SIG HPC Education YouTube channel within a few days, and I will let you know where that is, so you can show your kids that you are on YouTube.
That's true.
Yeah. All right. Thank you again, and have a good day. And thank you again for your presentation.
Thank you so much. Thanks for the opportunity.
Thank you very much, and you have a wonderful day.
Okay, bye-bye.
Bye-bye.
Bye.